Hello, everyone. Welcome to the session. This is Abhishek, and I have my co-host as well as Arkodit. So we'll be the host for the session. And in today's session, we're gonna learn about observability in chaos. And our today's speaker is Aravind Putrevu. He's from Elastic, and Aravind is passionate about evangelizing technology, meeting developers, helping in solving their problems. He's also a backend developer and has an 8 year of development experience. Currently, he works at Elastic as a developer advocate and looks after the developer relationship functions of India, Southeast Asia. Previously, he worked at McAfee Antivirus as a senior software engineer in cloud security domain. And also, you can, if you are in India, you can actually find him around a lot of conferences. He usually gives numerous talks. So, thank you, Arvind. Over to you.
Thanks, Abhishek and Arko. Thanks for a warm intro. What I want to do in the session is keep it simple and don't explain a lot of jargons and give a lot of theory. What I would like to do is like show you a demo and explain you a few things with respect to chaos and aftermath of a bit of like, or in the process of finding what's happening when things go crazy. That being said, at any point of time, if you have specific questions in the topic that I'm talking or in the topic that I'm or in and around or anything that is not related, please let me know, ask in the Q&A, and you can raise hands. The host would probably look and take questions from you as per the process. Also, you could type your feedback or questions. If you don't like the session, if you want the session to be more, if it's not related, everything, please go and put it out. Happy to go get to know about more about it. That being said, let me share my screen. So I hope you could see my screen. Yes. Maybe let me share my screen once again. Okay, application window. Great. So I am Aravind. I work at Elastic as a developer advocate, and I blog at aravind.dev, and my Twitter handle is @arvindputrevu. And that being said, I'm very interested in open source communities, free and open communities wherein people like use the software, give feedback, and I'm part of the Kubernetes Slack of quite some time. I used to attend. Nowadays, I was not attending the SIG contributors meetup meetings. So I'm also part of the OpenABS as well as Litmus Chaos channels. So if you are very much interested into all of this, please join, please contribute. Please work with all of us, and I'm really happy to work with the community, and then let us know about your feedback. So the talk specifically focuses on this stack, but then that being said, I know that we all discussed, or you've been hearing about chaos for last 24 hours or like last one day, and you've been hearing about probably like how to do this sort of chaos testing, or how chaos is a process, or there are several theories, and there are several practices that people share and work around, where I have been part of that as well. So that or I have personally unfortunately created chaoses at several of the systems that I have developed at various times or various stages in my career. So that being said, today we talk about something that is a issue, and that is a situation wherein how do you look into the analytics or the observability part of the problem when the problem occurs. And I don't think that I want to educate or give more knowledge about chaos itself, the process, or the systems and the reliability, etc. I believe, as you all know, that there are various definitions. But that being said, I'm thinking that when you say chaos, it's like wherein you have a specific, you want to test out your reliabilities of system, or various systems and the dependencies between them, how they are working. And you also want to check your blast radius of whatsoever the disruption that you are creating, and how much you are able to control it. And it's like pulling off the plug of a data center and checking out where you would where you would kind of like find out. But it's not just testing, and there are several other things that you could really learn from real world systems. There are many reports that I regularly read, like say SRE reports and all, wherein people, even after good enough testing, good enough understanding of the systems that they have purpose built for the software that they have written, there are still a lot of problems. Like for example, I think you can take Litmus Gas as well, the project itself as an example. They have playbooks for several of Elasticsearch use cases, wherein there are a lot of things that are probably not working initially for some reason, because of a new protocol that we have introduced or various other things, which was a bit of learning even for us. So that being said, let us quickly enter into the session. I think I have consumed again a lot of time. So the stack is Elasticsearch, Kibana, Log Session, Beats. I'll also show you the application architecture, but we are talking about the observability solution, like the specific solution that we are using to debug the entire stuff. There are many other things that we are not specifically looking at today. As you know, Elastic Stack is used by developers, professionals. I don't want to specifically call DevOps or DevSecOps folks, that there are a lot of people here in the continuous integration, continuous development. There are different types of roles that are coming in, so all the professionals are there, and there are like admins or people who are from the security background, infosec folks, and because everyone is a stakeholder in this entire system, which includes the product owner, who is probably looking at a specific number and probably reporting to a business leader and working on specific numbers. So multiple people, different use cases, different stuff, all do the similar sort of observability. If today we are talking about specifically an area. And then the stack is pretty agnostic, and the thing that I'm showing you today is on a specific cloud. Like I meant to say, the specific cloud provider, but then it's agnostic. It can be deployed anywhere. It can also be deployed in Kubernetes kind of platform. So there is an operator. I hope you might be knowing that. And then I'll definitely show you. I mean, there are few more links that I could give. I'm sorry. I think that link is there, but I'll show you that link. There are a few more links that I can show at the end, but let us quickly head into the the specific demo. So currently what I have is okay, I hope you are able to see my screen. If not, great, you were able to see my screen. I've got a Slack notification saying that there is a high mean transaction duration for an Edward service. So ideally, this is a application that I am running. This is the web store that I am running, wherein I have USD as my currency, and I have a bunch of products that are running here. I could click on buy and see what the product does, and then add to cart. And then I'm just going through a customer flow, and then I could place my order. The order is placed, and I could this is a simple usual flow wherein I could do all of this. And then the entire application is divided into multiple microservices. And if I go and show you this one, I hope you should be able to see this. There is there's a specific front end, a front end layer which is connected to a Node.js, which is taking which contains all the APIs to call back. And then each microservice is written in a different language. Then you have the checkout service, you have the Python for a search service, and you have an ad service main, which is connected to Elasticsearch again. There are multiple. There's a different services for different things. There's also a PostgreSQL connected service, which has the product catalog. Whenever we saw a bunch of products, so yeah, different services, each doing different thing. And the services, when I click on a specific service, it shows me the throughput, average memory usage, etc. Why am I showing this one? So the reason why I show is like not just it shows all of this, but also when you're doing CI/CD, or if you're running an application which is like as big as a large e-commerce house, and you want to understand when you're running a specific campaign like a Big Billion Day or a Great Indian Sale, or all of these the campaigns that people run, you want to do scale testing, right? You want to understand how the system performs at a specific place. And these are good numbers or specific things that you could know. I'm not talking specifically about this platform. Even in general, you might want to know all of these. And then I have specific services which does which gives you the latency. The metrics are latency, throughput, the error rate, and then you also have memory and CPUs as the regular metrics that you get from any infrastructure. So specifically looking at all of this, I also see, as per the demo, I'm not clicking from there, but as per the demo, you could see that the error rate in the test that I'm doing is around 91%. It's more than the usual, the error rate from other services that I'm there. So that's why I got a notification. If you could also configure other notifications, I could click on this, which will lead me to a specific dashboard. But then, like, these are the specific things that I have here, and then I'm going to show you in a minute. So it directly redirects me to the specific service and shows what is the score, etc., etc. So let me keep it that way for the time being, and then I'll also go and look at what else is there here. So if you see, I could go to full service details, understand what's happening in that service. I would also go and look at anomalies. There is a machine learning job that is configured. So end of the day, if you are looking at a specific incident, talking specifically about the test that you have conducted, or say that the specific the playbook that you have ran, you want to observe what's happening into that incident or a specific scenario. So and it might be generating a lot of data as well, because of the scalability of the or the complexity or the massiveness of the platform. Especially when you're talking about something like e-commerce or media companies, it might be very large as well because of the servers, etc. So here I'm just picking up the same thing, and I'm just looking at the request response flows. I'm just seeing some numbers here which says that the score is high. I'll not look into anything specific. I'll just go to the a specific job or something, and then I'll look into what is happening in my Kubernetes environment, what is happening in my application performance, why it is showing more errors. So I'll just go and look at my APM, and then say I'll go and look at my Kubernetes load. So let me go back and see what I can do here. So if the details are not loading so easier, so please bear with me, because I'm in a different sort of connection. And then it's status and apply time range, and then apply, which will give me a specific detail. As you could see that the Edward service is receiving a lot of anomalies, and then I have an anomaly score, which show this is called swim lane, wherein the machine learning job shows me what are the various scores that are generated. There are multiple graphs here, which for a newbie maybe you might not be able to understand what is that. But then I also have a different scores or details saying that what this transaction service. Usually you could also do all of this analysis or observability from the service map itself by just creating an alert, but it generates more alerts, and how many alerts you could configure. And at the same point of time, it's also about the signal to noise ratio. So what is a signal, what is a noise? So you need to define or figure out that particular part of the story. So here I have these different anomalies which are scored and ranked according to that. And then I could also go and see what this particular anomaly is asking me to look at. Say for example, like what is that service running on. So it's a Java service, it's running on Kubernetes, it's running on a specific pod, all of that. But you could also see what method is being called, and then why the errors are more, and what is a specific thing that is troubling you all. So here I could see that how the traces are being formed, and I could also see logs, but let's not get into that. I could see that it is going through a specific area, and then a lot of these things are happening. Let's come back and see what else other anomalies that we have. So as you could see, bunch of anomalies here. Like I could keep on going into all of these, like go view series and look into the data and understand. So the initial conclusion that we got from the Slack saying that high mean transaction duration for the AdWords service and the response times for the AdWords service so and so, so and so, so and so. So you could simply go to the AdWords service and also pick up the the what do you call I could pick up the errors, or like I could pick up a specific bar, and then I could go to the when I clicked here, I could go to the service, which is, I mean, the response that is taking longest time to respond. So I can click on that. It's showing me the shortest trace. I will go to the longest one, and then I could go by category and see, okay, see how it is being flown. So that's what I have done. So I have ran very fast. So that's what I have done. So that is one way to look at. You could also come back while the time persists. You could also go and look at other services, like this page shows you where the error rate is more. Say for example, the front end node is receiving more error rates. So what I'm trying to do here is specifically understanding what error has occurred, what performance impact that did it create because of a specific load that I have included in my system, and I'm just observing overall system how it is responding through this one thing. Say for example, the ads one is receiving or like the checkout one is receiving 10% error rate, and I could simply go and probably look at the one that took 12 seconds, and then I could go and look at the errors as well, which I didn't see. You see that this the entire email service is taking a bit of time. So there are various ways to go around on checkout. I'm just I'm just showing you randomly everything. I'm not going into a specific service. So let us also come back to that web service and see what is going on around in this particular thing. So you could see that that there are multiple methods that are creating error. You could see the library frames. You could see how the code has passed through and what is the code point that you are getting a specific error. Because this is a Java service, you'll also be able to see the JVM metrics. Like say you have this the specific pod that particular container is being run in. So you could also go and check out where this heap memory is being done. As you could see that there are specific spikes here, like wherein when the transaction latency is going up, or like it's taking a lot of time, you could also see that the heap memory being kicked off, and then like how things are falling and how the garbage collection is being picked up, and how all of this is happening. So there could be infrastructure like approach to this. If you have induced load, and like how the infrastructure is responding, should you add more containers, or how do you solve this problem? So you could do that, or you could straight away go and there is which I didn't talk about in all this time. You would also go to this particular dashboard, which is a dashboard for logs, metrics, and traces, wherein you could correlate all of that, wherein you could pick up and see where the service has restarted. Like you could also go and look at that. For example, let me see if I could select a specific, like say if I select a specific service, it will show me that particular services log generation cycle, if there are more logs that are getting generated, and how was the request response, number of requests that are coming in. So this is a correlation dashboard, and I didn't show you in the initial time. So you see that memory of service as well. So there are multiple metrics that you could go deep down in your incident and understand how how your response to the incidents, how your data can be analyzed. All the data is being gathered by the data collectors, open source data collectors. I think I didn't show you that. Okay, so I think as you know that we have been using FileBeat, MetricBeat, and APM agents here, through which we are collecting the data, and this is how the application is being connected just in the service map. However, it is there. I'm just showing you the same one here. So yeah, so that's the overall story, but then it's not done yet. So I could also show you the specific logs that have created this entire thing. So in the Edward service, let me go to the errors and see. Say for example, if I have okay, this is a bit latest, so I have got this error around a specific time. So say if I'm looking at the last 1 year of data, and then I'm looking at bunch of errors that are there, and I could pick a specific error, and I could pick again a specific transaction. Okay, I'm sorry. I'm right. So let me go to this page, and I could pick a specific transaction, and then I could also go to the logs that are there for the specific transaction, and look at how the logs were. And these are streaming logs, live logs, if you want that to be that way, or if you want it to be like, say, if you want to highlight a simple thing like catch miss, so you could highlight and see throughout the whether the keyword is being persisted. An additional thing that you could do is like you could create an alert if this is happening and this is being continued in a specific fashion. You could also create an alert, but this is an added thing that you could do upon all of this. So yeah, so this entire exercise is to understand how you could go through. This is not to again demonstrate that this is the only way to go around and solve the issue, but this is a simple way to understand that how you could organize and collect all the data, and probably analyze and understand and look at all of this. One last thing that I could also show you in this particular demo is you could also go and look it from a metrics angle, from the infrastructure angle. We spoke about from the application angle when you induce or look at load, how you go with the traces, how you find a transaction. From there, probably look at various things and errors, and probably again to come to logs. Now I'm going to show you around the metrics explorer, like the how the inventory is there. Say for example, if I say it's Kubernetes pods, and I'll say group by namespace, I'll be able to see what namespace is running what, and then I could search for Edward service, or which is there, but I could also go and look at logs, metrics, traces, or even create an alert. Soon you should be able to also look at the metrics, the tracks, and everything from here as well, or look at from the memory usage perspective, what is taking a lot of memory and what is taking a less amount of memory. Another thing that I'll and I want to show you more stuff. Another thing that I could also show is like the uptime metrics of each service. We didn't look at the service metrics here, but let me search for Edward service. So if you see that how Edward service is doing over a period of time, you could also come and look at from the ping or the status of it, what is availability, and all of these details, and you could go and look at what time it was there over a period of like last 1 year, how it is being performing. Is there anything different? Like I could also go and look at each one of these differently. So that is one another way to look at. If you have geo distributed stuff and then you want to look at each one of these in a specific fashion, you could go and look at from that point of angle as well. So yeah, so that's the story, and that's how I want you to take a look at observability from the point of incident analysis, or how you want to, when you make a change, how you want to when changes are being trickled down, and like how you want to compare and look at all of these things. So that being said, there is more now, and if you specifically want to look at what do you call, if you are looking at joining more of these sessions, or looking at all of these, please join our community. It's community.elastic.co. You have chapters. Nowadays it's all virtual, You can be on any chapter, be it EMER, or like you're from North America or South America, or like EMEA or APAC. You can find the virtual groups. You could join that. We also have a Slack channel. You could come and join and ask more specific questions. And more interestingly, we are also doing a community conference very soon. So, which is in the last week of February, and it's coming very soon. And like, please join us there as well. So that being said, I think interested to take questions. I want to show you more stuff, but then I think I've spoken a lot of time. I've taken a lot of time to tell a lot of things. I want to yeah.
No, it wasn't a lot of time. I mean, you're already on time, so no, it's not. So, by the way, it was really wonderful session. I mean, I find it really insightful. I hope audience also gained the knowledge from it. So we have two questions. So let me just quickly read it. So Karthik asks, when building Chaos experiment for testing an application stack with several microservices, is it recommended to have SLIs and thereby corresponding SLOs for each? Or do you think validating user-facing metrics is what matters?
See, there are several questions, several interesting arguments about both of them. When you're looking from a product manager, again, it depends on the management as well. And SLIs and SLOs are considered some sort of agreement between some customers. People ask for it. And then some teams take it very seriously to implement some of these. And when you ask me, like, or do you think validating user-facing metrics is what matters? So for when we are doing chaos experiments and want to observe what is happening throughout the thing, I feel that we are, as an engineer, developing the system and improving the reliability and understanding the issues in it. I think we should look at the second one, because we could still like probably achieve a good amount of the metrics that you have said, like SLIs or SLOs. But the second one matters more for me, because I want to go deep down and understand and test each and every feature. If it is dependent, say like in a large microservice environment, what if I pull a plug on, or what if I load a specific service more? What if the ads become more and people are bidding more ads? And how does the system perform at that moment? What does the orders are more, and how does the checkout service perform when the orders are more? So in fact, whatever I have shown is a replica of a real world stuff, and there are a lot of people who do this there are a lot of e-commerce companies who do this for the Thanksgiving or holidays.
Yeah.
And it's very interesting to know. And then probably very soon, and very soon, rather than doing scale testing or increasing infrastructure or increasing storage, or like doing all of this request based testing, people would tend to move to a lot of chaos based testing and run playbooks against each of their systems, which includes distributed systems and a lot of stuff. So yeah, obviously yes. I believe for the second one. Sorry for a very long answer, but that's the second one. But still, if you have a product owner, maybe he's still looking at the SLIs, SLOs, and all of this. So that is a large metric that he might be interested in.
Yeah, that would be project level. Yeah. So another one, I guess, after seeing the metrics that you were collecting, so he says there is an impressive amount of data being collected and rendered here. So is this like automated anomaly detection or predictive failure analysis available too, or it is just a planned thing?
Oh, you meant to say in this demo, whatever I have shown, or is it? I didn't get the question actually. So I was looking at the question. Is stuff like automated anomaly detection or predictive failure analysis available too, or is it planned? So I didn't get your question, Karthik. If you could clarify, that would be great. But from what I have shown you here, in general, I'm talking about in general. See, for example, when you have a lot of data being collected, the first response is to build dashboard for a specific metric. Okay, Karthik has clarified. When building chaos experiments for testing an application stack with several metrics, is it? Okay. he asked the same question.
It's on top. Yeah, it's on top.
Oh, as in planned as part of roadmap. Okay, good. So again, it's the same line of thought that I want to explain. So what I want you to think from a person who is running these tests or playbooks or anything, and then trying to make sense of it, trying to find things. So how it works for me is like I collect all the data somehow. Let us not go into specifics. Somehow I collect all the data. I probably build these metrics and probably look into these, dashboards. And then I realize that, okay, I'm looking at a lot of data. I just want someone to tell me when things get broken, or like when things change for every build, for every, because I want this to be part of my integration. And then when things break and I get some notification. But what happens in real world is like you probably might not have alerts for everything, or you might have more alerts for everything. So it is either one or this, because we can't expect every scenario, right? That's why we are also trying to induce chaos into our system, so that we better know what it is, right? So in this moment, what happens is you get more alerts or you don't get alerts for the important thing. That's where the anomaly detection comes into play, and that's where all of these random things or machine learning helps you to do them. So it could be planned in the roadmap, and when you have a lot of data and you want to make a signal in the noise, and you want your signals to be more evident when you have a lot of noise, when you have a lot of moving parts. In today's world, if someone I have seen startups having 15 to 20 microservices, even though probably they're a small startup. So it's very important when you have multiple things doing different stuff, and they're also talking to each other. They're not a distributed system, individual app sharded Kubernetes cluster, but doing individual things. And so that way, I should say that anomaly detection is a very important thing, and that's what even every observability platform is offering today. In not just Elastic, everyone is trying to do an anomaly detection to find out the trends, patterns, and intimate you when such thing happens. Yeah.
I hope Karthik, Arvind answered your question. So, guess we are already on time, but I don't see another question. Yeah, he says thanks.
Yeah, I think that's a great. I think Karthik, thank you for asking all the questions, and I really feel elated and to speak at the event. And I'm around. And then if you have any questions for folks who are listening on the chat and
Yeah.
or seeing the stream,
And we have already shared the Slack channel link as well. So if you want to ask question off to the stage, you can also join there and ask question to Arvind. So
yeah.
Arvind, again, thank you so much for your time. It was a wonderful session. See you soon.
Thank you. Bye
Yeah.
bye.